Good afternoon, everybody. And today we're going to talk about supposedly lecture number 7. I do have some good number of Google Doc questions, not that many, a small number. But I think some of them are still related to lecture number 6, which is okay. You can feel free to ask me questions in the earlier lecture. We definitely should deal with them as well. Because for your upcoming written test number 2, which I will speak about maybe briefly today, and then we definitely need those materials properly understood. Right, as usual, let me make some announcement, and then we'll get on with the technical details. All right, let's now talk about lecture number 8, week number 8. And to really motivate you to really get on track, week number 8 will be covered in written test number 2. Because we still have our not final. We still have our weekly Q&A sections next week to talk about your week number 8 lecture materials. And then the week after, Monday and Tuesday, you have your written test number 2. But I'll speak about it in just a moment. So they will be covered in your written test number 2. And it's actually quite natural for your written test number 2 to be more challenging than written test number 1, given the content that we actually cover after written test number 1, right? We talk about amortized analysis for the dynamic arrays. We talk about doubly linked list. We talk about some recursion, and we talk about also trees starting from week number 8. So definitely more challenging topics to be assessed in written test number 2. But just make sure, study your material and speak to me whenever you want to, right? We're going to sort it out, but before the test. It's going to be naturally more challenging than written test number 1. Then written test number 1, okay, and this week in week number 8, you're going to learn about general trees. Okay? Not only just the concept. I think for this course, I think understanding the concept definitely is a first step. But I think it's really important for you to also know how to really translate or transform your concept into some concrete coding, so you can see how exactly it works. So that's really the purpose for assignment number 2. So in your lecture, week number 8, I also talk about how you can implement the generic and general trees. But you definitely have to know what the difference is between general versus binary. You will see the detailed coverage in the lecture, so I'm not going to talk about it here. But in your, it will be part B. I believe it's B1 to B4. I actually spoke about how you can define some generic class for the tree node. That's like every node in the tree. Thinking this way, we talk about tree being nonlinear and the linked list being linear. So think about the tree, it's more like a generalization of the linked list structure that we spoke about. That's something I want you to keep in mind, and always think about how you really compare and contrast linked list versus tree. They do have some similarity, but you do have something that really exists in trees, but it does not exist in linked lists. For example, branching structure, which I definitely talk about when I talk about linear versus nonlinear. Pay attention to the explanation I made in the lecture. And after you have studied part B1 to B4, you will be ready to actually tackle assignment number 2. So I think maybe spend about 1 hour or so watching the part A and part B, and then for part C, which is about mathematical property for binary tree, you can maybe watch them maybe as you go with the assignments. You definitely don't want to wait for too long. I don't think assignment 2 is actually very heavy. It's only 2 methods for you to implement. I think both of them are actually quite thought-provoking. You definitely want to think about how to think recursively, right? And for assignment number 2, which I just mentioned, is actually released just earlier today. And just watch out the deadline, right? The deadline is going to be, I forgot. Anyway, look at your instruction PDF. And as you go over the starter code for assignment number 2 as before, I put all the important information on the comments and also some hints section. Thank you. It's March 22nd. Yes. And also the also in the assignment PDF, I believe it's section 2.3. I also gave you some hints for the second task that you're supposed to actually implement. That one there is actually not too difficult, but I would really like you to try to see if you can, task number 2, try to see if you can solve it within linear time. That's something you can think about. Just meaning that when you run, if you want to decide recursively, you want to make sure you don't really call the recursive, you don't try to make the recursive call too often, right? That's something I want you to keep in mind as well. All right, and assignment number 1 result was also released also earlier today. I think normally I wouldn't want to respond emails, like questions through email regarding your assignments or test grading result. If you got any concern about any grading, you're more than welcome to drop by my office hour. So there are 2 ways for you to actually express your concern. Either go to my office hour. Not today. We don't have any office hour today, but tomorrow for sure. And well, number 2, if you do believe there might be some errors in marking your maybe assignments, or maybe later on maybe your programming test, you can consider submitting a regrading request. And you can definitely refer to the latest like an earlier announcement I made from eClass. You can definitely see the procedure clearly laid out. But there is a deadline for the submitting the regrading request. Just watch out for the deadline. All right, so please just avoid sending me email regarding the grading question, but I'll be more than happy to talk about it during the office hour. I think that's much more effective when we actually speak to each other. All right, so finally, I'd like to remind you, before it's too late, about written test number 2. Let's take a look at the semester calendar, right? It's always remember where we are in the semester. We are definitely moving to the final 1/3 for the course, right? So of course we still got quite many interesting ideas to cover as well for this course. Just stay tuned. We definitely want to make sure you actually understand it before you finish your second year. Go to your semester calendar, right? We are now actually on the 9th over here. Okay, this is where we are. You can see you got the rest of this week. Around 11th Friday, I will send you some guidance about how to prepare for written test number 2, but the format is going to be just identical to what how it was for written test number 1. So for your written test number 2, it is going to be through eClass, just like the previous written test. I can tell you now. I'm going to confirm also on Friday about its coverage. But if you really want to plan ahead, naturally, it's going to be week number 5, week number 6, week number 7, and week number 8. So these are the 4 weeks of materials you have to study and make sure you understand well before you actually take the test. You definitely can get started preparing as well. There should be no surprise when I send you the guidance on Friday. And for next week, during the Q&A, we can definitely talk about any question you might have for the written test coverage, right? We've still got next Wednesday and Thursday. And then you got your written test too, right? The formats, the opening time, closing time in eClass are going to be consistent with how you was in written test 1, right? So hopefully you wouldn't have to get any penalty because you actually violated policy. You should be all right. All right. Alrighty, so that's about all the announcement I would like to make. Any question here? Anyone? Feel free. Any concern, any doubts about the course? Now would be the time to speak up. Let me know. Okay, hearing none, seeing none, but I do want to help you a bit on the assignment number 1. Let me spend about 5 minutes maximum. I'm not going to read over the instruction for you, but I want to point out some highlights you want to pay extra attention to about assignment number 2, not 1. I just got myself confused. Alrighty, so if you go to the eClass site, and then you can see we got assignment number 2 instruction, and also the starter project. Let me just highlight some certain parts in the instruction, and then I'll talk about starter project as well, just to let you know what should be the order in which you should really study or try or tackle to complete the assignment. Alrighty, if you look at the instruction here, well, that's the deadline, right? I'm not going to change it. It's going to be strict, okay? And for this assignment over here, we're still going to have the same programming requirements as before, like assignment number 1. The reason is, I think the main learning outcomes for this, for your assignment number 1, you try to build your linked list from scratch without the help of primitive array and also without the help of any library classes. We want you to achieve similar learning outcome for assignment number 2. So the main thing we want you to learn is really how to build tree from scratch, the branching structure or nonlinear structure of tree from scratch, and also how you can iterate through or how you can recursively actually manipulate the tree structure. That's really the thing we want you to really learn for assignment number 2 without the help of any library classes, because typically, if you try to call any library method, or even for primitive array, that will actually somehow, the structure will actually do something that you're supposed to learn. So I would suggest you just do everything from scratch without using them. So that will be something I would insist for your assignment, and also programming test. I think that'll be the best for your learning, from my judgment. Right? You may not agree, but that's the way it is. Right, so please make sure you don't really use any array, and you don't use any library classes for your assignment number 2. You don't want to get any penalty because you didn't know the policy, right? Right, so this is something I want to highlight first. And then everything else is very similar. Let me highlight to you the difference over here. And optional background study, the same as before, if you just want to review OOP, but at this point, I don't think you really you really need to, but just in case, I included the references there. And for the background study, this is actually what you were supposed to know already from about linked list. But for week number 8, general tree, you can definitely click on the link and see the link to the slides and also the lecture recording. And as I said, it's going to be part B that you mainly will need about the implementation details. Some simple implementation for you to get started with. Right, and I'm going to talk about this. Also, I want to show you the starter code. You want to also study carefully even before the starter test. So there is an additional JUnit test class I gave to you. It's called the test general trees. That one there is kind of similar to what I gave to you as the source code for the lecture week number 8. However, there's some subtle difference over there, which I will point out to you once I open the starter project. Okay, and also you want to read carefully about this section over here. There is some more intermediate use of the Java generics, which is quite useful. I think you definitely want to struggle through it in order to learn. Right, I already have written up something over here just for your information. Read them through. If you got any trouble understand it, ask me in the Q&A next week, or ask me during office hour. Okay. And then everything else is really the same as before, but just make sure you understand the policy about submission. This is important. You are given 2 methods to implement. So this hint over here is really about the second method, like about how you can generate the statistics for all the descendants of a particular node. So the input will be a tree of integers. Output will be a tree of strings. So your algorithm is really supposed to transform from an integer tree into a string tree, which is quite interesting for you to do. And so this one here is really about the visualization about the test cases I gave to you as a starter test. Namely, test get stats number 1 and also number 3. However, I will highly recommend the following. You can definitely look at the diagram here, just make sure it makes sense, but the better workflow will be try to go back to the specific test cases over here, try to see if you can visualize the link structure based on the code, the Java code, and then try to check your visualization, your diagram against what I'm putting over here. If they match, that means you really have no problem understanding what's going on in terms of what should be done. Because in your later programming test or the written, maybe not, in your later programming test or even exam, you might be given some similar fragment of code. So you definitely want to make sure you can visualize and analyze code like that. All right, but just remember there's some visualization over here to help you. Right, don't overlook that. Right, other than that, pretty much it. And just about the submission link, just same as before. Right, just make sure you submit promptly. Hopefully, wait in advance before the deadline. Right, you definitely got more than enough time to really do the assignments. I know that you're still pretty busy with other courses. That's why I didn't want to make it too heavy. But you definitely want to make sure you do the methods and then really think about exactly how to implement them, because you will be given something similar in the programming test in the exam. All right. Alrighty, let me just talk about the starter code over here. You may not have any question about assignment number 2 just yet. That's okay. You can maybe I'll speak to you maybe during the office hour. Let me just go over the starter project very quickly, and then we should really go into the Q&A. Okay. Let me say I download this project over here to my desktop, and I just want to walk you through quickly. Okay, desktop over here. I'll just open you using my text editor. I don't need to open that in Eclipse. Okay. Right. So if you look at that, the model package is simply just empty, right? Because you're gonna build something that's required over here as before. And under the tests package or folder, this is what you were given. The SLL Note stands for Syncly Link Node, Syncly Linked List Node. something like that. So this class here is identical to what you were given as the node class in assignment number 1. So that one there is very familiar to you. You're required to use it whenever you want to build like a list structure rather than array. Array is not allowed. This class over here, I want to show you very quickly. Sorry, let me close that. So this class here is called tree nodes. This is something I also cover a bit in part B of lecture week number 8. However, I want you to pay attention to this. In your assignment over here, since array is forbidden, I adapted to the requirement for the assignments, meaning that in order for you to store the child references, we use simply the head node and tail node. That's exactly how we did it for simply linked list, right? I want to point it out to you. And everything else will be, so these methods about how you can get all the children and also add a new child. So these might be good case studies for you just to see how to manipulate the tree structure. I'll leave them to you. Okay? You can definitely study them and reach out to me if you got in trouble. That's about the tree node class. And then let's now go to this class over here, which is called test general trees.java. This is not the starter code just yet. But this JUnit class over here shows to you how you can use the tree nodes together with the simply linked node together, right? Especially what does it really mean when you have some sophisticated type like this, right? So in order to figure it out, you can see the comments I wrote in the test and also in the PDF section 2.3, which I just showed you, right? Just make sure you study this carefully before you attempt the assignment. Otherwise, you will simply run into bottleneck a lot when you actually try to implement the 2 tasks. You want to make sure you really grasp the basic, which I prepared for you over here. All right, apart from this, one more. And of course, the usual starter tests over here. And I lay out all the programming requirements, and then you got 2 methods to implement. And you want to make sure you really know how to build or visualize a tree based on what we have over here. That's some exercise I also did briefly in the lecture week number 8 as well. So it shouldn't be too challenging for you. Right? Alrighty, so that's about assignment number 1. Do you guys got any quick question? Anything I went over is not clear to you, you can feel free to ask. Otherwise, I'll let you struggle with it a bit, and then we can talk about it later. Anyone? All right. Hearing none, seeing none. Okay, I presume everybody at least is okay. At least you know assignment number 2 has been released. And also, where should be the highlights you should really pay extra attention to. All right. All right, so let's now talk about let's see. Just one question here. Is it possible for me to give you guys the extra test cases for assignment number 1? I can see where Sarah's coming from. We don't typically really give out the grading tests because for the reason that we may have to recycle those grading tests for some similar assessment for later, either for the same course or for later course. However, if you guys really want to see like exactly what extra tests you felt for your assignments or programming tests, the best way to do it, I'll be more than happy to, just drop by my office hour or we can make appointments. What I will do is I'm going to download your submission and then I'm going to run it through all the extra tests together, and then we can go over exactly what you did wrong, what you actually felt for your submission. Maybe that can be also some valuable feedback that you're looking for. So Sarah, would that be okay? Okay, good. Yeah, sorry, just our policy. We don't really give out. We can give out solution, that's okay, but we don't really give out a grading test because we actually may need to reuse them later. All right. Yeah. So any assessment you want to review with me, just drop by. Right. Alrighty. So let's now talk about Google Doc question. Not that many. The first one is not really technical. For those of you who actually created a GitHub repository to store your projects for 2011, so let me just emphasize that because the 2011 is still active right now, the official end date should be maybe after you have seen your final grades. That should be the official end dates for the course. Before then, so please make sure everything you put on the GitHub related to the course, especially assignments and programming tests, if you want to, in that case, they must be private. Okay, so must be private before the official end of the course. which will be, you'll be safer to assume it's going to be end of April or early May. Around that time. After the course is finished, you can feel free to make your work, whatever work you did for this course, public. That'll be fine. Meaning that for those of you who actually took maybe 2030 or 1022 with me earlier, if you didn't know this, you can feel free to make your projects from the earlier first year course or second year course public right now, but not for 2011 because it is still active, right? For example, you don't want to get yourself into trouble. For example, if you actually somehow make your assignment number 2 public, and somebody might just Google and somehow find your solution and copy that. In that case, you will be considered as enabling plagiarism. In that case, you will be responsible as well. So you definitely want to protect yourself. So that's why I want to mention to you. All right. Right. Should be quite easy to understand. Please obey that. And the second question over here. That one is more from week number 6. That one is easy to clarify over here. From your week number 6, when they talk about the stack example, and we talk about 3 applications there, reversal of the array, and also how we can match the how we can match the parentheses, brackets, etc. How we can match the delimiters, and also how we can actually do the postfix calculation, right? So these are the 3 applications we did in the stack. And for the first 2, I actually somehow declared the method as static. So is there a reason for that? Well, I would say being static or not over here is not going to be the focus point, right? So the reason that, let me just tell you why I declared it to be static, and also it will be more appropriate in this case, okay? It is static because, number 1, the method itself does not need to use any attributes in, remember this method was declared under the context of stack utility class, in stack utility class. Every time if you have such method which doesn't really depend on the attributes in the residing class, in that case, you may just want to consider making that static. So every time you make a static method, that simply means the method can just work with its own parameters, in this case, just the array, right? So that means this method only operates on the parameters, only operates on the parameter, in this case, just the array, right? And to really, and number 2, given that it doesn't really need to use any attributes, so we can make it static, in which case we don't really need to create any context objects in order to call the method. What do I mean? Stack utilities, you can just mention the name of the class, and then dot reverse. That's all you got to do. And then pass some array. Alternatively, if you're thinking that whether or not you should actually say the following, you might be thinking maybe stack utilities, let's say maybe SU will be new, whatever it should be, and then you say SU dot reverse over here. If you did this in Java, over here, it's actually going to give you some warning saying that you're actually calling a static method which does not require any context objects. So that would be a warning, not really an error. So you can still execute your code. It's not really compilation error, but it might show some lack of understanding. So whenever you want to use a static method, you definitely can just invoke it using the class name, not the context object, right? That's something I presume you may have already learned it, maybe from the first year. But if you have any doubts about it, if you want to review static, you can feel free to go to my lecture site, maybe for 1022. You'll find the relevant part if you want to review, right? We wouldn't review the details in this course. All right, so this one here will just be a warning from Eclipse. All right, and the similar arguments for the get like a matching delimiters method as well. That's why we make it static. However, I do want to point out the main thing I really want you to pick up programming wise is about how to declare generic parameter at the method level. I think that one would be more interesting for you to learn. meaning that you're not actually going to, the E over here is not really corresponding to the generic parameter declared at the class level, like a stack utilities. If you look back to the source code I gave to you, the stack utility class is actually not generic. And we only got generic methods at the method level, right? You can see the generic parameter is only declared at the method level. And we did this for the reverse example, right? So you can pick up the syntax and see how to do it, right? I think you can definitely adopt it maybe for your maybe personal Java project. I think it's a very useful feature to have. Right, any follow-up about this question here?
Hi, sir.
Yes.
Just one thing about the generic method
Yes.
that you said.
Yes.
What if the class is generic, and will it be possible to use like another variable name like a t, and then have?
Good question. Very good. So Adnan asked a very good question. Let me write it down. Very good question. Let me say this. If I say public, let's say my class, and then I can put as many generic parameters as I like. So far, we have only seen example where we got only one generic parameter. I think we'll see an example about two when we talk about the map ADT around the end of the course. We'll see that, but you can get as many as possible. Okay. And the question was, what name can we use for generic parameter? What names can we use as generic parameters? The answer will be somehow similar to what kind of names can you really choose for variables or parameters. The answer would be you definitely want to choose something that wouldn't clash, right? So the answer would be, I'll write it down precisely. The name over here, any name that does not clash with two things. Number one, any library class name. For example, if you put over here, let's say array list, it will be considered as clashing, right? Because array list is actually a valid name that's already reserved by one of the Java API. So any library class name cannot be used as a name for generic parameter. And the second one is classes created in the current projects. Let's say for your project for assignment number 2, or for your project for programming test 1, in the same projects across the packages, classes created under the same projects. Yeah, for example, let's say if you already got one class in the same project called my class, or list utility, let's say, maybe called list utilities. In that case, this class presumably already exists, has been used, so you cannot also use it. So the typical name for generic parameter is, I think for Java, they like to use E, they like to use I, they like to use K, and also V. Typically, it should be a single character. You don't want to really use like a entire word or compound word, even though syntactically that's correct, but it's not really the convention. Single character in uppercase. The Java convention is like this. I know for other languages, they like to use maybe G and also H, I, and J, and etc. But doesn't matter. I would say if you actually choose maybe around these characters over here, you should be safe. All right. And then, does that answer your question?
Yes, it does. But we could use two different generic parameters in a class, right?
Yes, you can definitely declare more than one. Yes, indeed.
Okay, sure. Thank you.
Yeah. So the example you will see, maybe not the coming week, but definitely either the second last week or maybe the last week, we're going to talk about like a mapped ADT. In which case, you need one generic parameter for the key, and also the other generic parameter for the value. So you will need 2. I will see that when we get there. Yeah. Alrighty, good. All right, guys, any more follow-up to this question over here? Anyone? Alrighty, let's now move on. The next one, why do we need to assign null to the return array? Why do we need to assign null to the return array elements when we pop from an array stack? So your fellow student was wondering about the pop method implementation for array stack, right? So I just included it over here. So if you see, that's what you were given in the lecture array stack. Let's now focus on the pop method over here, right? If you recall, either the precondition is violated or we do try to pop, right? So what we did was we tried to say result is simply assigned to the current top, right? Remember, the top index is t, and then we assign data at we assign the current top to be null and the decrement t, right? Of course, your fellow student was somehow wondering, why do we need this? Is it okay to get rid of it? I would say programmatically, well, if you programming wise, if you simply get rid of this line, you might still be able to pass all the test cases for the stack, because the way we actually get access to the stack is really by the top index over here, just by t. So it might still be okay. However, I wouldn't recommend you do that. The reason we are doing this is just to be consistent with, let me write it down. The reason that we are writing this way is to make sure t should be let me even put it this way. Our notion about using t for the stack, two things, two angles. Number one, t indicates where the top is. Let me visualize it right away. Let's say this is our data stack, data array for the stack implementation, let's say, all right? Let's say if currently we are now here, okay? And let me just give you a little bit of a quick review, or heads up if you haven't really gone that far for the lecture, right? This implementation over here is really about the fixed size conventional array implementation for the stack, and also similarly for the queue. Meaning that if we actually got to the point that, not this one, let's say for the push, if we got to the point that the maximum capacity has been reached, we don't really have a way to resize the array. So that's why we also got another part of the discussion about how you can dynamically change the size of the array. And you also need to know how to really derive the amortized running time for that. We had some very detailed discussion about it. Make sure you follow that, right? I want to remind you. And let's go back to here for this simple scenario. Apparently, this part over here will be the top of the stack. And to the left over here should be all the valid items in the current stack, right? That's really important to see that. So, okay, you know what? Let me just use this part here. You can think about everything to the left of t, including t itself, the index. So these are the valid items of the stack. Symmetrically, anything that's to the right of the t index, they do not belong to the stack. They are yet to be maybe assigned whenever you do any further pushes. They are not part of the stack. Right? So that's the second point I would like to mention. Items stored at indices strictly larger than t are not valid stack items for the current stack. If they are not really valid, I would suggest they shouldn't really store any objects, meaning that once you have already popped the current top, let's say you pop the current top, in that case, you're going to move the t to the left by one position, so t should really be here. In that case, whatever object that used to be the top over here, it should be garbage collected as soon as possible. The way to do that would be, we want to assign this one to be null. In that case, no reference should be depending on this object anymore. But of course, there might be other references from other application. In that case, of course, the object will still be here. But typically, this object once has been detached from the stack by assigning the reference to null. In that case, this object should be garbage collected soon. So in some way, that's also good memory management that you can do. All right. So not valid. Okay. They should be detached ASAP whenever possible. So this is why we are actually having this line over here, right? I think that this line, this one here is not, even without this line, I think your program can still be correct in terms of passing test cases, because we're only using where the T is here to really control where the stack is. However, I would say to really keep our array clean as possible, in that case, I would suggest really have to include this line as well. All right, so that'll be my response to your fellow students. All right, any follow-up to this? Anyone? I hope that's clear. All right. And let's now move on to the next one. All right. The question is about the dequeue method in a circular array. Okay, sure. And the dequeue method in the circular array has to be void. I presume the void simply means it should be a mutator method. Indeed. So you can see the dequeue method. Oh, sorry, I included the wrong fragment. But dequeue is, you know what? Let me just make it right. Okay. Bear with me. Just give me a few seconds. Okay. I want to get it right. So let me see. It should be for the queue. Let me copy the right fragment so we can talk about it. Let me copy this one. Okay, let me delete this. Okay, that should be good. All right, that's the queue, right? So your fellow student was really talking about the dequeue method over here. Right, dequeue over here. Okay, so when they said has to be void, that's actually not right. Because remember, you really should talk about the interface for the queue, right? So the method over here, the header, this header was declared in the queue interface. If you just recall the diagram we drew in the lecture slides, at the top we got the queue interface. At the bottom we actually got several implementing classes, right, for the same interface. We got array queue, we got linked queue, we got stack queue, and also we got circular array queue, etc. Right? And so that's why this part over here you really have no choice, since you actually choose to really implement the queue interface. So what your fellow student is saying over here has to be void. That's actually not right. It should be an accessor returning whatever element you actually dequeue, right? The old front element. And there's also some misunderstanding I can see over here, which I want to also point out. Rather than returning a new array like array queue, your fellow student was implying that in the dequeue method for the array queue, we try to return a new array over here, right? Not true, right? We are not really returning a new array. Rather, what we're doing here for the for loop over here is like this, right? Let me just mention that quickly. It is true we are creating a new array as the intermediate stage. However, we are not really trying to add up any more space. That's not what you're trying to do. Let me show to you. Let's say before the dequeue, let's say this. If I got q.dequeue, right? So let's say this is the method we are trying to call. And remember, when we talk about ADT and modularity, we talk about before like a pre-state and post-state, right? Before the method was called. So this will be the pre-states. Just remember the terminology, right? It might also be covered in the written test or exam, right? And also after the method is called, it's called the post-states. Let's think about what's happening over here. Let's say in the pre-states, we have our data array for the queue. it is pointing to, let's say, over here, right? So we got the rear index, okay? So we got index 0, that will be the front of the queue, always, all the way to, let's say, this is R, okay? The rear index, meaning that this part will be the valid contents for the queue, this part over here. This part over here is simply just unused, right? It's before the dequeue. After the dequeue, what we expect to see, well, let's think about what's going to happen for the dequeue. We basically want to get rid of this element over here, assigning that to null maybe, but it's not enough, because in that way we will be having some empty slot as the first one. We're wasting spaces unless you want to make a circular array, which will address exactly this, but that's not the point. For the fixed size conventional array, if you want to get rid of this part here, what you gotta do is you want to shift everything to the left by 1 position, right? So what you want to do is you want to basically using the same array over here. So think about it's still the same array, still data, right? And then what you would do is think about this part over here. Let me see the blue part. This part here is really everything but the front. That part there is actually going to be shifted to the left by 1 position. So after that, we're actually going to have still R, but this part here is only going to be the blue one, just this part over here. Think about this part here is really this part over here. How do we do that? We need to use a loop to shift the element everything to the left by 1 position, right? So we are not really returning any new array, absolutely not. We're just returning whatever first element we are deleting. That's what we're doing. So there's some misunderstanding here in the question itself, which can show, but I'm just clarifying that. All right, guys, anything that's not clear? If you want to ask a follow-up to this. And one tip for you, you can definitely take these two as the review question for your written test number 2, right? That's actually really something I kept emphasizing in the lecture. So question number 1, right? Given the array queue, we found different limitations. Number 1, why do we need circular array? Circular array. And question number 2, why do we need another kind of array? Is called dynamic array. Dynamic array. Why? Right? For each one of them, if you've already followed through the lecture, you should know the answer. But if you haven't known the answer, you will find out. That's something also very important. Rather than simply saying, oh, since Jackie is teaching circular array, so I should learn it. Not really. You should really know why we're doing that, right? Given this very naive initial implementation for the queue, and you want to know what kind of limitation does it have, so that we have to create circular array and also dynamic array. Because if the original implementation is really already working perfectly, there's no point to introduce anything new. So you definitely want to know what's really the connection over here. So that'll be some suggested review question you want to do for you prepare for written test 2. All right. All right. Any follow up to this? Anyone? Yeah, indeed. I think the circular array and also the dynamic array, I think both are very interesting ideas. It's definitely something you wouldn't think. Think about what you're learning right now. What we are really learning right now, think about 1 year before, when you were studying maybe 1021 or 1022. At that point, you thought maybe manipulating loops like a while loop, for loop will already be very complicated. But you can see what we're doing now. We are just getting to the next level. That really suggests you're growing as well, right? Intellectually, what we are learning now. Once you get to 3101, I think you'll simply move to just the next level about the different kind of challenging stuff. Alrighty, seeing none, hearing none, let's now move on to the next one. Okay, I think we got just 2 more. Okay, this one over here, it's related to one of the slides. Let me show you the slides first. Your fellow student was just wondering about if I can speak more about how to implement a queue using 2 stacks. I definitely can do example together, right? Let me show you which slides this is about. if you go to, I believe that one should be about the exercise we did. Maybe it should be lecture maybe 3, D1 or D2. I forgot. Should be D2. I think should be D2. Anyway, you check it. But if you go back to the slides, for example, and you will see that one of the slides about a queue. There we go. This one here. All right, it says slide number 46, right? And this one over here just talks about how you can actually implement a queue using 2 stacks. I can talk a little bit more detail about it, but I will highly recommend you actually try to implement it and test it in Eclipse. That'll be the best way for you to see exactly how it works. I can give you a little bit more example and some conceptual sketch of how it works. All right, let's talk about it. And you want to, first of all, realize that the stack queue class that you're going to create will implement the same queue interface, like the circular array queue, the array queue, and link queue, right? They are all implementing the same queue interface. And we actually got 2 attributes over here. We got in stack and also out stack, right? We'll see exactly how they work in a moment, but both of them are simply just stack. And you can see the stack over here adjusts the static type for the attributes. Right? It's also very important to remember about polymorphism and dynamic binding that we learned from 2030, right? So these are the static type of the attributes. Dynamically, you can actually assign the any objects that's a descendant class of stack interface, which will be array stack, link stack, and etc. Right? That's something we also mentioned in the lecture. I just want to point it out. And we got these different operations for the queue, and we want to see how we can implement them using 2 stacks internally. All right, let's see exactly. And what I will do is, let's consider this fragment of code. And I think this might be good hints for how you can really test your stack queue later when you actually finish your Java implementation, right? You can also try to adapt this as well. That will also be a good hint for you. Let's say we got some queue storing string, just call it queue, right? And let's say we are dynamic binding, we're going to use the stack queue, exactly the class we're implementing over here. Let's say we're trying to enqueue, and then dequeue. Of course, it should really exhibit the FIVO property, first in, first out, right? Let's talk about how the client is going to perceive the queue, and then we'll talk about supplier in a moment, okay? And if you talk about this part over here from the client's point of view, it's going to be basically, that's how we visualize a queue, right? So what we'll do is we're gonna enqueue Alan, Mark, and Tom, right? So Alan will be here, and also Mark, and then Tom. And of course, our convention is this part over here will be the front of the queue, right? So now if you try to dequeue over here, 1, 2, and 3. When you try to do dequeue, this will be the first one to be dequeued. This will be the second one, and this will be the third one, right? Agree? Very simple manipulation for the queue. That's only from the client's point of view. Now we want to see from the supplier's point of view, they are going to use 2 stacks to simulate the queue. That's the interesting bit, right? Guys, by the way, I think that this is a very old-aged interview problem that people like to ask during the coding interview. But because it's so well known, so people may not ask that anymore because it's so well known. But I think it may not hurt to actually know about it. Maybe you're lucky. Maybe when you get to your interview, your employers will just simply ask you how you can implement a queue using 2 stacks. In that case, bingo, you know how to solve it, right? All right, let's now talk about from the supplier's point of view. How is it going to work? Right, so here I'm including already the hints I gave to you about the conceptual sketch, but let's just see exactly how it works. From the supplier's point of view, we got 2 stack, right? We got in stack and out stack. Okay, let me write it down. In stack. Also out stack, right? We got in and out, okay? Here's the principle. If you're doing enqueue, you always simply push the element you want to enqueue into the in stack. All right, that's okay. Enqueue over here, the principle will be you simply just push to in stack. In that case, you're going to push Alan for the first enqueue. Second enqueue, you're going to push Mark, right? And then the third one, you're going to push Tom. Think about what's happening here. When the client say, I want to enqueue Alan, in turn, it is going to correspond to a push of Alan into the in stack. Of course, this push is not visible to the clients. It's only internal details for the coding for the supplier. All right. So far so good. We have done the 3 enqueues. So we got Alan, Mark, and Tom. And how do we do dequeue over here? Think it this way. What if we don't have this out stack over here? Would it be okay whenever we say dequeue, we simply just pop off the stack and return that right away? Would it work? Well, apparently it wouldn't work, right? You can see if we did it that way, the first one to pop out of the stack will be Tom, which does not match the first one that should be dequeued from the queue, which is Alan. Because these two data structures fundamentally are different. One is about FIVO, the other one is about LEVO, right? So that's why you cannot really directly using a single stack to simulate a queue. But how do we simulate the queue by the introduction of an additional stack called alt stack? How do we do that? So that would be the trick, right? So if you look at the description over here, okay, if you want to dequeue, there are 2 cases over here. You want to look at alt stack. If it is not empty, in that case, you simply pop off the alt stack and return whatever it is at the top. However, if like right now, if the alt stack is empty, that means you're going to get it prepared. In that way, what you're going to do is you're going to pop off everything from the in stack and then push them into the out stack. In that case, you will be able to get a reverse of the original stack, right? Let me just do this one here. I think that the dequeue is really the trickier option. You want to make sure you're convinced. For these 3 dequeues over here, right? Basically, okay, you want to first pop all items in stack. Okay, one of the stack, and then push them to the out stack. That will be step number 1. Step number 2, you pop off out stack. This is the case where the out stack is actually empty. If the out stack is not empty, you can just pop off. You don't need to actually get any items from in stack. You don't need to. Okay, let's do it. Step number 1, we're going to, well, of course, you're going to work out exactly how to pop off every item from the in stack and then push them into out stack. That will be some programming exercise you got to do by yourself. All right. Of course, if you struggle with that part, you can let me know. But you should be okay. That one is not really difficult. So pop off the first one, which will be Tom. Put it here. Second one will be Mark. And then third one will be Alan. And so that's why for the first dequeue, we got to do this preparation job, and then we will be able to actually pop this off, which will be Alan, which is matching exactly what the client will see, right? Alan and also Alan over here. Alan and Alan. And what about the second dequeue? The client is expecting to see Mark. In that case, we're going to pop off the stack, in which case we'll get Mark. The third dequeue is going to be Tom. From the client's expectation, in that case, we're going to pop off the last element from the out stack, we'll get Tom, right? So I'm going to say 1, and then the second pop will be 2, and the third part here will be 3. You can see the 1, 2, 3 over here is matching 1, 2, 3 over here. Right, let me recap. So to really see why this works, you really want to think about what's really from the public client's perception about how the queue works, about FIVO. From the client's point of view, you want to understand about FIVO. From the supplier's point of view, you're basically trying to simulate the FIVO property using two, not just a single one. You cannot do it just by a single one. Two level stack. Right? So that's about the little elaboration I would like to make, which I couldn't actually do in the lecture. But I'm glad you asked. All right, guys, any questions about this? Like about simulating a queue using two stacks. Right? If you have a study buddy, you can definitely practice. Maybe try to maybe do some role play, right? Maybe one of you will be the interviewer, the other one will be the interviewee, and then you can ask the question about how to really implement the queue using two stacks, and then you'll try to explain to your study buddy about exactly how this works. Yeah, even if you think you got exactly what I'm trying to say here, when you try to explain it by yourself, it may not be so straightforward. You definitely want to practice, right? Any follow-up to this before I move on to the last question? Masato, go ahead.
Hello, Jackie. Sorry if it's a bit loud. The sandbox turned out to be quite noisy.
Yeah.
But I know this includes this week's lecture as well. But yeah. How would the average runtime was it? The ammo. Sorry, the word's not coming clear. Right? Yeah. How would that look like for this? Because I understand that, for example, more specifically for dequeue, because I understand that popping out of outstack, if it's full, or if it has something in it, is O1. Yeah. But if you have to move something over, that's ON. So I was wondering how we could balance.
Very good question.
Like how we can take the average.
Yeah, thank you. I got it. I'm glad you asked. Yeah, let me now talk about it. Yeah, Masato, if you can mute yourself, that'll be great. Thank you. Now. Thank you. So awesome. Yeah. Right. So let me just I will give you guys some hints over here. Let me Masato question basically is about the exercise about running time. And I said if you want to see the analysis, you may just want to see the analysis on amortized running time on dynamic array. Let me now draw some connection to you so you will see why I said it that way. These two examples turn out to be incredibly similar when you want to analyze the amortized time. Right? Of course, I'm making the assumption that you have already studied this part over here. If you haven't, maybe come back to my summary over here, maybe later. All right, let me now talk about it. All right, so we talk about basically two examples. One will be the amortized runtime of, let's say stack queue. Let's just write better. Right, so the stack queue is basically this class that we spoke about, right? That's one. And then over here, okay, I'm going to use a table to summarize. The other one is the amortized average runtime of dynamic array. Let's say that's also for the queue. You can definitely, you can definitely use the dynamic array for implementing a queue or stack, right? But let's say we'll talk about a queue, right? And what I want to do is I want to talk about specifically some method over here, right? Let's say in the case of the dequeue over here. Actually, for both of them, we actually. So in the case of a stack queue, we talk about dequeue. Okay. And in the case of the dynamic arrays, let's say for the queue, we talk about the in-queue method. And if you recall, the way we talk about a dynamic array for the queue is, when you actually reach the maximum capacity for your array, that actually already preset. In that case, you can grow the size either by doing doubling or by doing increments, right? Let's say we do the doubling for now. Let's say we do doubling. Right? So here, dequeue over here, you want to think about what's really the worst case. As Masato correctly pointed out, the worst case will be big O of n. And the reason is because to really, let's say, push items popped from in stack. Let's say push items to the out stack. Sorry, let me write better. I definitely can write better. Let me do it again. I think this comparison is really important. Big of n because pushing to the out stack items that are popped from the in stack. If you remember what we did over here, initially, if the out stack is simply just empty, in that case, we have to pop off all the items over here and push them into here. That will be big O of n because this in stack over here initially contains all the in queues of items that we have got so far. In that case, we gotta push all of them into the out stack. So that's why that part alone is going to be dominating linear. All right. This part over here is really analogous to the case of in queue, the worst case. The worst case over here for the in queue for doubling strategy is also linear because you have to copying items to the resize array. Right? For the details, you can definitely refer to the lecture. I just want to summarize the point. Right? So far, we can see some similarity over here. So both of them simply linear time. However, there is a very important insight over here we should know in both cases. However, such transfer of items from in to out stack happens rarely. What do I mean? In this case, initially, we have to transfer all the items from in stack to the out stack because out stack is empty. Once we have done that, for the subsequent dequeue, we don't actually have to do that anymore because we got some non-empty out stack, right? So it doesn't really happen that often. Okay. Also, it's similar for the resizing strategy, right? In the case of dynamic array. However, such resizing of array is not needed often. All right, so far so good. It's really important to see over here. For the dequeue and also for the inqueue, for these two scenarios, the worst case, no question, just linear, worst case. However, when we actually talk about amortized case, you want to think about how often does such worst case really occur. It turns out you can average out such linear time over n different pushes or n different inqueues or n different inqueue and dequeue. That's something you can actually argue. So eventually, I believe you can derive the amortized runtime for this will be big O of 1. And similarly, as we did as the exercise, if the amortized runtime for that is actually big O of 1. So that's really the comparison I would like to draw. So if you really want to prove this, you're gonna do something very similar to what we did for the doubling strategy arguments. You want to somehow maybe assume you're now talking about maybe n inqueues and also maybe n dequeues, something like that. And then you want to assume what's gonna be the you're gonna analyze what's gonna be the pattern for the transfer of items, and also what's gonna be the pattern of simply popping off the stack for the out stacks more specifically. And then you're gonna analyze the average out runtime. That's what you're gonna do. Masato, does that kind of make sense to you so far?
Yes, it does. So I just want to clarify one thing. So for that, to get to find the pattern, do we start with like the worst pattern and then get the best pattern and then take the average of those, or?
Yeah, you definitely want to think about the worst pattern, because when you calculate the average time over here, you definitely want to think about in the worst case pattern. In that case, what's going to be the average time? Something like this. For example, let me switch up. Yeah, so Masato, if you can mute yourself, please.
Oh, sorry.
That's okay. No worries. Okay. Yeah, just it wouldn't drive everybody else nuts. All right, so let's see this. Over here, one possible pattern you can think about. This may not be the correct one, but I'm just suggesting. So one pattern you can try to use to analyze about the run amortized time. One pattern. It could be, for example, you try to do enqueue. Let's say you do. Let's say over here enqueue all the way to some enqueue over here. How many? Let's say we got n enqueues. Oh, sorry. Here to here. Let's say we got n enqueues, n operations, n. And apparently, after this particular pattern over here, we got exactly n items in the in stack over here, right? And then what's going to happen if we try to do, let's say, dequeue? And since we got n items in the queue, conceptually, we should be able to dequeue for n times. Over here. And in that case, you can also call that for n times. Right? You can see the only expensive dequeue will be just this one over here. This one here definitely is going to be big of n. However, for all the subsequent one, for n-1, it's going to be big O of every n-1. Every one of the n-1 dequeue is going to be exactly just big O of 1, right? You just pop off the out stack, given that you have already transferred all the items into the out stack. So each one of them will be big O of 1. And if you actually do this, it's going to be basically also big O of n altogether. Right? So the amortized running time, let me sketch it. The amortized running time will be big O of, this is n, this is n-1, n plus n-1, for example, and then divided by, how many dequeues are we talking about? We're talking about n dequeues. And this is definitely going to give you big O of 1. However, what we haven't really covered so far is whether or not this pattern over here is really the worst pattern you can think of. Also, you need to argue. Yeah, so that's something I'll leave to you. All right, but this will be just one example. You got to think about different ways of interleaving the enqueue and dequeue. For example, what if I say enqueue followed by dequeue, enqueue followed by dequeue, and etc.? Would that be a worse pattern, or would it not? Masato, would that be okay so far?
Yes, thank you.
Good, very good. Awesome. All right, guys, I think it's a very little bit more advanced usage of our asymptotic analysis, but I think it's not too bad, right? It's just using some basic math that you definitely learned earlier. But I think we can really analyze some very interesting scenario, especially about average running time. Okay. Any follow up? Any question to this? Everyone's good? Alrighty. Right. One more question here. That one is about a binary search algorithm, which we gave to you in the lecture. That one apparently is a recursive algorithm, right? You can see we're making two possible recursive call, either this or this, either go to the left or to the right. It says that we can implement this without recursion. That's true. You can definitely implement a binary search iteratively. We can simply keep updating the front and to in loop. Yeah, I can let you do as an exercise if you want to implement it iteratively. So let's say without a recursion using a loop. So you guys can take that as an exercise. Implement binary search using a loop. Right? That's an exercise you can definitely try. And the reason I did it in the lecture was because that lecture was meant for recursion. So that's why I want to show you the recursive version for the binary search. But a little bit look ahead of what we're going to do. Week number 8, we introduced the idea about binary search. But in week number 9, we're going to talk about something called binary search tree, which is a very fundamental concept to understand. I'll leave the detail to the lecture itself, but I want to give you just some connection to why we first talk about a binary search, like a recursive version, binary search tree. In which case, if you talk about the general shape of binary tree, right? You got a root over here, you got a left, you got a right. The left can be arbitrarily complicated, and also the right can be arbitrarily complicated as well. And because the binary search tree, in order to be a binary search tree, rather than just a simple binary tree, you ought to satisfy certain so-called search property, which I will detail in week number 9 next week. Okay. Once you got a binary search tree, if you want to search for some elements in the tree, in that case, you will be able to only go to one branch, but not both, because the search property is somehow satisfied. You can either choose to recur on the left subtree, or you can choose to recur on the right subtree. Every time let's say if I recur on the left, that means I have truncated the search space by half, given that the tree is actually balanced. Right? I'm talking about another idea about the binary tree, which is called balanced tree, which we'll be talking about maybe most likely week number 10. But we'll get there. I just want to kind of connect things together before I even talk about it. Once you actually, so this way of doing the search in a binary search tree is exactly how we do binary search on a sorted array. So that will be kind of the connection we can make maybe later when we get there. That's why I want to talk about this. All right. But exercise, you can definitely try to implement this iteratively. And later on, I'm going to draw some connection between binary search tree and also this binary search on the linear structure. I'll talk about the connection between these two later. All right, any follow-up? Anyone? Alrighty, we still got 10 minutes left, roughly. There's no point to keep you longer if you don't have any questions, but I'm going to open the floor once more. Do you guys have any questions about any part of the lecture? And we still have two more chances next week, Wednesday and Thursday. We still got Q&A. Come back for questions before you take your written test number 2. Where exactly do we check our assignment 1 marks? Please go to eClass announcement. That one I got precise instruction for you. Okay, just go there and then you will see a precise instruction. If you got problem following that, please let me know. All right, good. You're welcome. Good. Let me see. Yeah, exactly. That's a comment I recommended, right? Yeah. So anyway, so guys, please read the eClass announcement. I got precise instruction for you there. Yeah. You like the penguin stickers in the lecture. Thank you. Yeah, good. Yeah, I will try to just make the lecture a little bit more interesting. I got penguin, I got pigs, I got panda, I got many others. Well, you guys will see more later. Anyway, that's not really part of the the learning outcomes for this course, but thought I'll just make it a little bit better. All right, guys, thank you for coming today. My advice for you, try to catch up with the lecture if you haven't, and then we definitely have to make sure you actually are okay with all the lecture contents before you take the written test number 2. It is going to cover week number 5, 6, 7, and 8, including this week, which I just released today. And if you got any question before that, definitely reach out to me. And I see 2 more questions over here. You try to command on the red.csc server. I couldn't get in to run it properly. Masato, can you drop by my office hour tomorrow, and then we can let you share your screen. We can take a look. That'll be the best. How about that? Tomorrow. From Ednan, are we going to have in-person Q&A later? I'm really planning that. Tentatively, I want to do that maybe for the final 2 weeks or final 3 weeks. That's what I really want to do. So let me check it, and then I'll get back to you. I'll definitely announce it earlier. All right. Alrighty, you guys, you take care, and then I will talk to you later. Bye-bye. Bye for now.